In this video, I will be showing you how to model this hex bit. This part is pretty tricky and uses a revolve cut. Alright, the first thing that we want to do is make sure that our units are correct. Right now we see it's in millimeters gram seconds, which is the unit that we want. Next we will edit the material. And the material will be stainless steel, and we can just search it up in this handy search bar, hit apply, and we see here that the material is applied. Our first feature will be an extrude on the top plane, and we'll be starting off with the bigger of the two normal hexagons. So a hexagon has 6 sides, we'll leave that at 6. And now we have our hexagon, and we can go ahead and dimension this distance to be 6 millimeters. To fully define this hexagon, we make this point horizontal to the origin. And now we finish the feature using a boss extrude to a length of 17 millimeters. Alright, and now for the next feature, we will be making the smaller hexagon, which will be from an extruded cut. We can start off with a sketch on this top face. We repeat the process. We dimension this distance as 4 millimeters. And again, we make this point horizontal to the origin. Now we can make an extrude cut. We select flip side to cut. We will let this distance be 5 millimeters. In the drawing, it looks like it might be appropriate to use 4 millimeters, but we'll have a 1 millimeter fillet that we need to account for, so the extrude cut will be 5 millimeters deep. Speaking of that fillet, we can make that feature now. The radius will be 1 millimeter, and we will select this edge, the edge that connects the smaller and the larger hexagons. There's a little option here that lets you select all of the edges that are connected to a loop. This is our part so far, and now we will create the final feature, which will be a revolve cut. It's very important that you use the plane that when you are normal to, it will show 3 faces as opposed to 2 faces like this one. For me, that plane will be the front plane. So we'll start off with this little chamfer. We'll just draw a right triangle, and then we'll dimension this angle to be 45 degrees. And this horizontal distance to be 1 millimeter. Next, we will define the chamfer on the top. We do the same thing, we make a right triangle, making sure that we don't accidentally snap onto any of the midpoints, otherwise it might be a little annoying to delete them. Delete the relationships. Make this 45 degrees again, and this time we'll dimension the horizontal line of the triangle, and that will be 0.5 millimeters. Okay, and now we will be making a circle and give it a radius of 4.5. Select the center, hit shift, and select the perimeter of the circle. So this will have a radius of 4.5 millimeters. And then the distance from the center of the circle to the top of the part will be 4 millimeters. Before we define the circle, we select the edge and make it tangent to one of these vertical faces, one of these edges. Now we can see that our sketch is fully defined. We will be making a revolve cut. In order to do that, we need a center line. The center line should be connected to the origin. So we have everything looking nice, and we can do a revolve cut. Make the axis of revolution the center line that we made. SolidWorks should automatically do that, and then we'll have the cut go all the way around, so 360 degrees. And voila, our part is finished. Finally, as a final step, we should make sure that our mass properties are consistent. That's the finished part. Thank you for following along with the video.